In this lesson, we'll quickly go through a problem, and that problem consists of finding the resultant of a set of forces as shown in the figure. We can see that these forces, they represent a general case of forces in a plane because only two of them are parallel, others they are not parallel, and obviously none of them they are concurrent at a given point. We'll try to walk through the steps needed for solving this problem. For that, let us first establish an x and y axis. Okay, let us say this is the x-axis. Let us say this is the y-axis. Let me quickly mark them. This is x-axis. This is y-axis. Okay, the first step of finding the resultant completely is finding its magnitude. To find the magnitude, we'll find what is the x component of the resultant or x bar, and then y component. This x component of the resultant is the sum of x components of all these forces, 200, 750 and 4200. To find out the x component of this force, we'll quickly note that this angle is 30 degrees. Because this 200 Newton force is a vertical force, it doesn't have an x component. This 700 Newton force, it is going into the third quadrant, so its x component is negative. So 700 cos 60 degrees. This 500 Newton's force is again a vertical force. It doesn't have any x component. And this 4200 Newton's force, it is having an x component of 4200 cos 30 degrees. Because it is in fourth quadrant, its x component is positive. If you punch in the numbers and find out, you will get this Rx is 3287.30 newtons, and it is along positive x-axis. Okay, then you can find what is Ry bar. Okay, that is the y component of the resultant. Okay, this Ry bar is the sum of y components of all these forces. Y component of the 200 Newton force is minus 200 because it is going along negative y-axis. Because the 700 Newton force is in third quadrant, its y component is negative 700 sine 60 degrees. And again, the y component of 50 Newton force is minus 50, and the y component of this 4200 Newton force, which is going into the fourth quadrant, is minus 4200 sine 30 degrees. So if you punch in the numbers and find, you'll find that this is minus 2956.22 newtons, and this is going down along the y-axis. Once you have this Rx and Ry, you can find the magnitude of the resultant R as under root Rx square plus Ry square. You can substitute these numbers given here to find that this resultant is 4421.04 newtons. This is the magnitude of the resultant. Then second item we need to find is the quadrant in which the resultant lies, and the angle which the resultant makes. Okay, we know that if a force is in first quadrant, its x component is positive, y component is positive. If a force is in second quadrant, its x component is negative but y component is positive. In third quadrant, both the components are negative, and in the fourth quadrant, the x component is positive and y component is negative. We will say that since this Rx is greater than 0 and Ry is less than 0, R lies in fourth quadrant. And in fourth quadrant you can show this as, you have this x and y axis, you have the force R as shown here, and the angle we define as this theta. This tan theta we can write as magnitude of Ry by magnitude of Rx. So we can write theta as tan inverse of magnitude of Rx is 2956.22 and magnitude of Rx is 3287.30. So this angle is 41.96 degrees. Okay, so we found that it's making an angle of 41.96 degrees. So having obtained these two pieces of information, we can write or we can draw this resultant to be going somewhat like this, going down somewhat like this, making an angle theta as shown here. Okay, having found the magnitude of R, which we found here, magnitude, the quadrant in which it lies we found, and the angle we found, and what is left for us to find is are two things. One thing, what is this distance from here to here? That is the point where it intersects the x-axis. Let us say this distance x. Okay, to find that out, let us say we drop a perpendicular onto this. Okay, this is perpendicular, and let us say length of that perpendicular, that is from here to here, perpendicular is L. If we can find L, we can find this distance x. To find that L, we will write an equation for Varignon's principle. Which says that the moment of the resultant about any point is the sum of moments of the individual forces about the same point. So we'll try to take moment of this resultant about, let us say, this point O. About point O is R multiplied by its perpendicular distance L. Because it is causing a clockwise moment, we have minus RL. Okay, this should be equal to sum of the moments of individual forces. This 200 Newton force does not contribute any moment because it is passing through the point about which we are taking moments. Now this 700 Newton force, we can resolve it into two components. One component Ry as shown here. Okay, and another component is going along this Rx. Okay, this Rx you can see is again passing through the origin, so it doesn't contribute any moment. This force, which is 700 sine 60, contributes a moment, and again because this moment is clockwise, we use it a negative. So the moment due to 700 Newton force is 700 sine 60 multiplied by 1 minus 700 sine 60 multiplied by 1. Okay. Similarly, the moment due to the force 50 newtons is 50 multiplied by 2 with a negative sign, because that moment is again clockwise moment. The same way we can find the moment due to that 4200 Newton force by extending it here, and then noting that you have two components. One component is a vertical one, another component is a horizontal one. This horizontal one is x component of the force. This x component of the force is passing through the origin, so it doesn't contribute any moment. The y component, which is 4200 newtons multiplied by sine 30, will have the moment, and that is acting at a distance. You have 1 meter plus 1 meter plus 1 meter plus the distance from here to here, we can quickly find out, is 2 divided by cos 60 degrees, because this angle what we are showing here is 60 degrees. So we have 1 plus 1 plus 1 3 plus 2 by cos 60. Noting that we can have the moment of this force, which is 4200 sine 60 going down, okay, as 4200 sine 60 multiplied by 3 plus 2 by cos 60. If you simplify the whole right hand side and cancel the negative sides on both sides, you have RL is equal to, if you punch in all the numbers, 15406.22, and the units will be Newton meters, from which we can find L is equal to 15406.22 divided by, we have magnitude of R is 4421.04. So this L comes out to be 3.48 meters. Once you have this L, you can consider the triangle. If this point is O, this point is A, and this point is B, you can consider triangle OAB, in which angle A is 90 degrees and this angle is, we have already computed, theta. So you have sine theta is OA by OB. We know this OA is L, and this OB we are calling X. So you can have X is L by sine theta. And we know the value of theta, we have already computed, 41.96. So this X is equal to, you will get it, 5.2121 meters. And almost all the problems on finding the resultant of a set of forces, a general set of forces in a plane, constitutes 3 steps. 1, finding magnitude. 2, to determine the quadrant and the angle, and 3, to use variance principle and locate where the force. Typically we locate it by where the force intersects the x-axis. We'll try to see a few further problems on moments and vector notation in subsequent classes.